Hello, everyone. Very welcome. How are you doing? Good. Very nice to see you. Probably everyone is getting ready for having a weekend. Before everything, I'm gonna just quickly bring it to your attention. I've already posted an announcement about your test tool. Not sure how many of you noticed about it. If not, it's right in here, as you can see. I've prepared two types of tests as a review for your test tool. One of them is like very similar to test one, which is many solve problem in order to help you to prepare properly, have enough source. An additional one for test two, since for test two, you're gonna have multiple choice questions included inside the test. Therefore, I have prepared another type of review, which is multiple choice question, very similar to what you experienced during the quizzes, weekly quizzes inside the class, but I've prepared a completely separate version, including multiple topics which are in like a part of your test. So therefore, you may want to just consider it. It's not available right now. The actual problems, yes, but not the multiple choice question. That one is going to be available from March 23rd to March 30th. And you are going to have 2 attempts in order to complete it. Why is unavailable? Simply because some of the topics are not still covered. Therefore, I don't want you to go there and lose your attempt while still some of the topics are not covered. So you have option to practice it closer to the test too. Another maybe information in here. Some of you ask me about your assignment 4. Assignment 4 is not today. Always I inform in advance, but still from the beginning of the semester, the course schedule is posted and available to everybody on the Avenue. Therefore, it's going to be 2 weeks from now. It means 1 week before test two. Again, there's a purpose behind it to make sure you are going to push a little bit before, or let's say before the test time to study, not to accumulate everything for the test two and become heavy for you. So I plan to have it 1 week before test two to somehow force you to start studying a little before the test. Maybe you feel so like that, but to be honest, I do it because I want to support you to manage your schedule a little bit. So kids, today's topic is, let me just go ahead and share my screen. And if you remember, today's topic is about wiring. I have left some of the slides about the wiring for electrical system in here. I'm going to start with just a little bit more information about how to do the wiring for electrical system, more specifically for automotive application. And then after that, before the end of the class, I'm going to solve one problem for you on how to design your maybe 2 lights for your automotive in case you are going to do it for preparing your automotive in order to maybe carry something from here to do. So I'm going to solve a problem right in there as well. So let's start with a little bit more about, remember, this is where we have left last time. I introduced the wire size. I introduced the wire colors, the American standard. Hopefully everybody can remember. If not, the previous lecture is posted. You can go watch the previous lecture. But a quick review, you can see right in here in electrical circuit, when we are focused on wiring, therefore wiring is not something that just grab a wire, connect it from here to there. Definitely, as I discussed last week, lots of factors are super important in order to have a proper, efficient wiring system. One of them is like the length of the wire, and of course, the colors doesn't have technical impact, but it will have like impact on organizing the system, troubleshooting. But the thickness also is super important. Another factor which is super important is being able to read a wiring circuit, or let's say a wiring diagram for any electrical application, more specifically for automotive application. Quickly, I'm gonna review the information. In case you forgot about them, let me just clean it up and do it one more time. As you can see right in here, there are lots of information on this example. Suppose this is your headlamp for your automotive. Look at here, you have like the thickness of the wire and the color. 0.8 is like the thickness of the wire. PPL stands for the color, which is purple. And then you have in here the connector symbol. Do not get this one wrong. This is not the direction of the current in the system, right? If you are going to draw direction of the current, you don't draw it on the wire circuit. You are drawing in the actual electrical circuit. Therefore, this is talking about the connector. What does it mean? For any connector which is going to connect to different components, or the wiring from two different components, you have male and female, right? Therefore, what you can see in here, this is going this side, this is going to be the female, and this is going to be, this is male, and this is the female. So that's the symbol for the connector on wiring circuit. You do have, like, again, in cases the wire is coming with two color, you do have it with a slash. For example, here purple and white are the combination of the two color. And then you have the circuit number. This is the headlamp, and again the wire size, the wire color, and so on. So now let's look at another schematic, or let's say another first symbol and then a schematic, in order to become more familiar. Having that in mind, another requirement for wiring diagram is being able to understand wires in the circuit are tripping over each other, or they do have real connection. Sometimes also we call it nude if they do have a connection, or the two wire, they are going to at least in one end be connected. But more specifically, we are calling it a splice. What you can see right in here, this is what we call it, a splice. A splice means the two wire, they are shown that they do have a field dot. These two, they do have a connection, right? Sometimes you may see that there are many splices inside the circuit. Means those are the connection, and those are not the wires tripping over each other. Sometimes if you want to draw wires tripping over each other, if this is one of them, the other is supposed to trip, you have to show it with something like this. But if you have it with like a field dot or circle, it's gonna be a splice, or nude means they do have a connection. About the connector, I'm pretty sure you have experience seeing different type of connector. In here, I'm having like two of them. Each connector might have female and male in case they are going to connect either multiple devices, or I would say the wiring of the multiple devices. And as I said, the symbol in electrical circuit is not like, for example, very similar to this one. It's going to be very similar to arrow like this for female and male. So this is again another example of it. So another thing that I need to add right in here. This is important to know, like in addition to, for example, the details for the wiring circuit, you need to know, for example, we have 500 to 599 locations for the wiring from the front, and of course from the right front and left front. And even if you are going to put them inside the wiring circuit, if they are on the, or connector, if they are on the like left, right in here, means they are, for example, left front. If they are here, it means they are right front. So that's the way that we are showing it. From top to bottom, I'm gonna just explain this one for you. What does it mean if I'm having, let me maximize it, if I'm having something like that? How do I read it? Let's practice reading this one together. If I'm having some like symbol or some circuit, this is hot at all time. But what does that mean? This is hot at all time. Simply means this is the ignition switch, right? This part. This is the ignition switch. You hit it or you start it. Then right after that, based on the information in here, means this ignition switch is connected to terminal B. This is what we call it, the symbol for terminal. Means this switch is connected to terminal B, connector C2. Make sense? This is how we read a wiring diagram. Ignition switch is connected to terminal B, connector C2. The wire is yellow and the thickness of the wire is 0.5 and the circuit number is 5. Make sense? Right? See, it's like a story. You have to have a story behind of it. And then after that, it's going to terminal B3, connector 202, means connector 202 is in between B3, which is terminal again, and this is again the connector. Remember I said the connector is like an arrow. This is not the direction of the flow of current. So it means this connector, which is the number 202, is connected to terminal B2, B3, and then again the color is the same, the thickness of the wire is the same, still the circuit number is 5, and these two connectors, they are connected to each other, means B3, terminal B3 and terminal B6 are connected through connector C202 and connector C101. And of course, as I said, means this one means female, and this one in here means male. Means the male of C202 is connected to female from the C101. This is how you can read and understand an electrical like wiring circuit. It's super important to be able to understand it properly. More specifically, if you are going to either troubleshoot the system if there is any trouble, or if you are for the first time trying to follow the circuit or to follow the schematic and start designing the system or start creating the prototype of the system. In addition to that one, also I've already explained some of the symbols in this lecture, in the previous lecture. Let's quickly look at some of the typical electrical and electronic symbols. So for example, positive, negative for any source, energy source, or I would say voltage source. If it is like just showing the positive and negative, or let's say polarity, you just show it like that. But if you have a battery, you have to include those polarities on the side of the battery. Of course, if it is a battery like the taller side is positive, if it is shorter, it is negative. Ground has two different symbols. This is more common than the other one, but of course, both of them are correct. You can choose either. Fuse is important to understand because also in this lecture I've taught you, and I show it in previous slide, but this is fuse. Circuit breaker also, we discussed circuit breaker in the previous session. Resistor has two types. We have two types of resistor. Either it is variable or it is constant. If it is variable resistor, what do we call it? We have it in the lab. We continuously use it. Potentiometer. Yeah. If it is variable resistor, there is an extra arrow on top of the resistor. If it is just a constant value, we don't need any arrow. And so on. The rest are, for example, diode and many other. Capacitor is another thing that we continuously use it since we are practicing DC motor. And of course, stepper motor. This is also the symbol for the stepper motor. In this course, we don't practice transformer, but it's good to have some understanding of delta connection and Y connection of the transformer, which is advanced electrical engineering courses, how to design transformer. Is not in the like concept of this course. So another thing that I truly want everybody to know it before I start solving a problem and designing how to properly include a relay in your system in order to design your customized maybe light for your vehicle. I would like to introduce relay. Relay is an electromechanical device, right? It's not pure electrical, it's not pure mechanical. So we do have coil, and the coil in total, I'm gonna say relay has 4 connectors, right? 2 of them are directly for powering and 2 of them is just for the coil, right? So for example, if you are gonna troubleshoot a relay, since you have 3 connectors in here, 4 points in here, you have to grab like your multimeter, you have to check 30, number 30, this is like this, the number for it is 30 and ground to see if it is functional or not. Or you can check another one in here, which could be, for example, 87. It's not showing it because I maximize it, but the number in here, I'm gonna minimize, you can see it. This is 87. Either this part or this part. Check it with multimeter in order to check the functionality of it and see if it is receiving the power. But if you are going to check the actual functionality of the coil, you have to check number 86 and 85 using your multimeter or ohmmeter. Well, you can see, for example, these two are connected. I mean, 87 and 30 are connected, and 87 and 30 is like your for high amperage. Therefore, if you want to check the functionality of them, just use your multimeter. Here you can see application of relay in a system, as you can see right in here. Suppose that you are having like two lights, which is going to be added to the back of your truck. And this is exactly what we are going to practice, how we design such a system for ourselves. In this one, you can see I'm having a relay. If you are seeing inside the relay is open, what does that mean? It's normally open, right? You know, contactor, relay has contactor, right? And symbols for contactor of the relay, we had it last semester in mechatronics. Can you remember? In mechatronics, we had like relay design inside the like circuits design, and there are two symbols. If we have it like this, means normally open, but how is normally closed? Yeah, so right now I'm having it normally open. Means this relay, its contact is normally open. And then remember, I just in the previous slide show you the symbol for fuse. That's why I say this is important to at least remember what are the electrical symbol of electrical component. For fuse, this is a symbol. And then I'm having battery. And I just said, what is a splice? A splice means there is a connection between the relay and the existing light in the vehicle, because there is like this field dot, means this is a splice, means there is a connection in there. These wires are not tripping over each other. So I already explained what to do if I'm having a faulty relay. And this is the wiring schematic. We had it in the previous slide. Having that in mind, let's go ahead. This is the problem we are gonna solve. Keep in mind, this is going to be your vehicle. You are planning, this is your car. You are planning to maybe connect a truck or whatever to the vehicle to transfer some stuff from here to there. And since at the back of this, you need to have like a signal for the other passengers or other drivers around, it's better as an engineer to go ahead and just connect maybe two lights. But those two lights, if you want to control them, like with your, when you are inside the cabin, inside the car, therefore you have to have a proper wiring for being able to control it. So that's the plan. We are going to design how we can connect the lights to the back of the truck and control them from inside the cabin. So let's do this together. I'm going to just prepare some space in here. If you want to practice with me and take a note, you are more than welcome to do so. Otherwise, I've already included this one for you on the avenue. You can look at my solution in there as well. Either will work, is totally up to you. So I'm gonna start with drawing the circuit. We just had it in the previous slide, but in order to make sure you can understand the detail of the problem. So suppose I'm having like two lights. Remember, for electrical system, having a ground is mandatory. If you don't ground the system, it's not gonna work. So I'm gonna start from grounding, right? So I'm gonna connect one light to left, one light to right. Suppose this is the light, and this is also a symbol for light. It might not be the best drawing, but at least it will give you a good understanding of what I'm doing right in here. So based off the question is asking, you want to add tail light with total power of 260. What's the symbol for power? P, right? So I'm going to consider, I'm going to have my power to be 216, and the unit is always for power watts. Remember, I already in the previous session, I said even what is the equation for power? Who can remember? VI, right? VI. So right after that, you're supposed to have your trailer, this one to be connected to the trailer, and turn them on with your car headlight switch. We do have a headlight switch inside the vehicle. Suppose I'm gonna just whatever type of headlight switch you have in there, just the way that you turn that one on at the same time, this light's supposed to turn on as well. And then you want to consider the distance to be 20 feet from your main. Why I'm using the distance? Simply because another important consideration for design is like being aware of the length of the wire and of course the thickness of the wire. Length is important, thickness is important. Who can tell me why and what's their impact? Why thickness and length are important while we are trying to design a system? You know it, didn't say it. I know you know it. 100% correct, because it will directly impact the amount of the power we are receiving from the source and we are passing to the load, whatever the load is. In this example, load is the light, right? So now I'm going to consider including a relay. Pay attention, this is electrical symbol for a relay. And I'm going to have it to be normally open as we show in the previous slide. In order to have it normally open, this is the symbol, right? And of course, for the relay, we have also coil. How do we show the coil? Like this, very similar to the inductor, right? But inside the square right in here. And of course, again, relay is supposed to be grounded. And the other side of the relay is supposed to go to the headlight, right? Remember I said this is going to be connected to the switch for the headlight and turn on and off accordingly. So I'm going to connect this one to another light, which is going to be my, by default is changing. I did not do it this way. So this is going to be my headlight. I show it with HL. And these are my L1 and L2 at the back of the truck. Then the question is asking, consider the distance. And this is the wire, which is considered the distance, means this one. So I'm going to consider this one to be 20 feet from the question. And then, of course, I need this to go to a fuse. So it says your distance is 20 feet from the main 12-volt battery from the source. And I just said power is equal to VI. You want to add taillights with total power of 260 watts to your trailer and turn them on with your car headlight. The taillights have distance 20 and your main battery, which is, where should I put the fuse from the previous session? I need to include the fuse right in here. How do I include the fuse like in electrical circuit? What is the location? Who can answer this question? I said it before, that's why I asked it. Any idea? It's okay. Fuse, what's the application of fuse? How about that? Who knows what's the app? Why we, yes, please. 100% correct. Only wire? The devices too, right? Therefore, if I'm planning to protect my wire and any other devices connected to that wire, where should I place it? What's the best position for the fuse? Before the source or after the source? 100% correct. Therefore, I have to place it right in here. And this is the symbol. It's like a tile, right? And right after that, I can include this one to be my battery. So this is my fuse, right? And this is my battery. Therefore, I have to include it right after the battery and before the relay, because if the fuse is sensing something which is not normal, then the relay causes the connection to be disconnected. And then I'm going to protect my loads. In this case, my loads are my LEDs. So I don't need the question anymore. All I need in here is the table just for your reference. Therefore, I'm going to leave this table for your reference. I'm going to maximize it. You can see it on the side, and we are going to use it in order to complete the problem. So how do we now solve for such a problem? Now, we need to find the proper wire and proper fuse, because now fuse is a question. We know that we have to have a fuse, but we don't know what fuse is the best fuse for our application. And of course, we do have the length of the wire to be 20 feet, but we do not have the gauge. Therefore, I have to even find what's the gauge. How do I show the gauge of the wire? What's the symbol? What's the symbol? That's one, AWG. That means the thickness of the wire. Therefore, my variable in here to find is the right size of the fuse and, of course, the right size of the wire. Battery, it was given already. It was given what is the battery size. It was 12. So now let's go ahead and solve for this one. So having those in mind, I'm going to say P equals voltage time current. I already have like power and I already have the voltage, but I do not have the current. Therefore, I solve for the current. Means P by V. Means 216. Remember, we had it before. It's right in here. 216 watts. And for the battery, we had it from the problem to be 12 volts. Therefore, I'm going to have my current to be 18 amp. So far, so good. Now, based on the current and distance from the power source, we can select proper wire gauge. Remember, this is our variable to find. Based on this table, so we have to have a good understanding of this table to be able to do it. So I'm going to say from AWG selection table, this is what we call it. Remember, AWG. From here, I'm going to say if I have current to be 18 and voltage to be 12 and distance to be 20 feet, now let's figure out what is AWG. Look at the table. Before I say it, you come up with some idea. Is this clear enough? Somebody just come up with some idea. Consider this requirement. Current to be 18, if this is my current. If this is my current, let me show, this is my current. And then voltage is given. Voltage supposed to be 12. And I'm having length. Length also is this one. Now, how do we find it? We say current 18 means which one? Current 18 means this one. So far, so good. And then we have the length also 20. Then I have to just simply connect them. So if I have 20, and if from here I have 18, then the intersection is going to be 40. Make sense? Then I can say, based on those information and based on what I can find from here, the best answer or the best option in here is the wire to be 14. So I'm going to write it in here, AWG. Remember, this is the size of the wire. Is going to be, the proper size is going to be 14. AWG 14. So far, so good. Now, you learn how to read this one, kids. This is important. You are going to have similar question for your test. Therefore, try to learn how to read the AWG table. Makes sense? That's important. Easy, but important, okay? Now, another question is, so far I found this one is going to be 14. Another question for me is now, what is your fuse size? Let's like in here, practice how do I find my fuse size. We have for the fuse also some fuse rating. In order to look at the fuse rating, fuse is rating 20%, more than this is the rule. But let me write it. Fuse is rating 20% more than nominal current of the circuit. Keep it in mind, always. For any application, this is the rule. Now, I'm going to just solve for it. Therefore, I'm going to say fuse rating equals, what was my current? 18, right? 18 amp. And if I have it 20% times 1.2, it becomes 21.6 amp. So, but do I have any 21.6 amp fuse in the market? No, we don't. Therefore, we have to just round. We select 20. 20 is available. Therefore, we select the fuse to be just 20. Make sense? We need to select the lower fuse rather than the higher fuse. What is the reason? Because what if I can, for example, instead of 20, instead of coming down, what if I choose 22? What would be the difference? Yes, please. Yes. What if between, like, because this is something like between 21 to 22. It's like 20, 21, 22. If I pick 22, I'm skipping anything close to 21, right? And I don't have this one, therefore I choose something lower than that, which is available in the market to still stay in the safe side. And if I'm having closer than 21, still it is covered. Make sense? Why is that? So this is it. Still, anyone who has a question, feel free to ask. It's important to learn how to calculate fuse rating. It's important to learn how to calculate or how to figure out what is the right size of the wire for your circuit. This is one example, but this equation and this method of calculation is general. You can use it for selecting any proper fuse or any other wire for any other application. If any question, feel free to ask. Otherwise, we can just finish it up right in here. Still, I'm available in case you guys have any questions.